Hi there, and welcome to Learn About Electronics and our video on transistor technology. We all use millions of transistors every day without knowing how they work or how they were made. Well, here's a short video to help you understand this vital component. Bipolar junction transistors are fabricated from an ingot of pure silicon using many complex steps to make microscopically thin layers of specially treated silicon laid on top of each other to produce the required NPN or PNP structure of the transistor. The first step is to produce a thin slice or wafer of silicon that is first polished and given a protective coating before the process of producing a large number of transistors on each silicon wafer begins. The transistors are laid out in a grid pattern formed on the silicon wafer, and once the transistors are completed, they are electrically tested, and any transistors failing to meet the required standard are marked with a die and discarded, as the wafer is cut up into individual transistors. There are many versions of the silicon planar process used to form transistors and integrated circuits. Here is a simplified sequence illustrating the basic steps required in fabricating each of the single NPN transistors. The process starts with a layer of heavily doped N-type silicon that has a low resistivity. On top of this, a thin layer of lightly doped N-type silicon with a higher resistivity is chemically grown. Using a photomask in ultraviolet light, the area inside the mask is softened to allow the thickness of the layer to be reduced by etching with an acid solution. A layer of P-type silicon is then deposited in the recess to form the base of the transistor. Again, an area is masked off to allow etching of part of the P-type silicon, forming a thin layer for the transistor base. In this recess, another layer of low resistivity N-type silicon is deposited to form the emitter. Finally, areas of aluminium are deposited to form the emitter, base and collector terminals of the transistor, before thin wires are attached to connect the transistor to the external connections of the completed transistor package. Here is a completed power transistor. Let's look inside and see the actual silicon chip in place. Notice that here, because this example is a power transistor with a metal body, only two connecting wires are used for the base and the emitter. Remember, the bottom layer of the chip is the collector, and so is connected directly to the gold-plated body of the transistor. This also helps to dissipate the heat generated when the transistor is conducting. Okay, so now we see how a transistor is made. Let's see how it works. Here is a bipolar junction transistor in animated format, complete with the external base emitter and collector emitter circuits. It has a heavily doped N-type emitter, a lightly doped P-type base, and a heavily doped N-type collector with a thin, lightly doped N-type layer next to the base. The base emitter voltage VBE and the collector emitter voltage VCE are both at 0, so the transistor is turned off. Although a small voltage is applied to the base, VBE is still too low for the base emitter junction to conduct. Electrons can't cross the base emitter depletion layer, even if the collector voltage VCE is switched on. As the base emitter voltage gets close to 0.6 volts, the base emitter depletion layer becomes thinner, and a very small amount of current begins to flow between emitter and collector. With the base emitter voltage VBE just a little over 0.6 volts and the collector emitter voltage VCE present, the transistor will conduct fully. The collector current can now be 100 times greater or more than the base current, which is due to some of the free electrons combining with the positively charged holes in the P-type base material. Very large changes in the collector current can now be controlled by very small changes in the base current. The transistor is now acting as a current amplifier.